Hi, Autumn. I asked Peyton if she wanted to talk to you, but apparently she's angry with you. So sorry about that. Maybe on Monday. We'll see how it goes. So it's not like anybody's going to try to find this video on YouTube tonight or anything like that. So no big deal. All right, we start with real numbers, just a very general discussion. Okay. So real numbers, natural numbers. If you teach a kid how to count, what do they start with? 1, 2, and 3, and so on and so forth. Okay. We use a symbol for natural numbers. It's an N with 2 lines at the beginning. Those are your natural numbers. Because it's what comes natural to us as people to start counting. Whole numbers include another number. What is it? 0. Now you may say, well, zero's, just obviously part of the number set. There are many, many years in this world where people did not have 0 as a part of their number set. They didn't understand the concept of 0. It took a while for different cultures to figure that out. Integers include another number, another set of numbers. What are they? The negatives. The symbol we use for integers is a Z. Looks like that. I'm now going to make a statement. You tell me if it's true or false. All integers are natural numbers. That is false. Give me an example of a natural or of an integer that's not a natural number. -1. Make another statement. All natural numbers are integers. True or false? True. And you can see that that's how this is organized. All the natural numbers sit inside the integer set, so they are also integers. Okay. Now we have rational numbers, and the root word here is ratio or fraction. So can you give me an example of a rational number? 1/2. -5/7. 10/5. It can be simplified to 2. A 2 can be written as a fraction. That's why it's included in this set. We have other examples. Say 0/-17. That's still 0. What about 0.45? Is that a rational number? How could you express that as a fraction? 45/100, which can also be written as 9/20. So you can see, one that sometimes throws people for a loop is 0.3 repeating. What is that as a fraction? So it doesn't, it can repeat. It's okay if it repeats. The symbol that we use for rational numbers is a Q. These are all part of the real number sets. To say that there are real numbers suggests that there are fake numbers or imaginary numbers. A mathematician who discovered imaginary numbers said, what good will ever come of imaginary numbers? We're sure that there was no practical use for imaginary numbers. Well, 100 years later, a guy by the name of Leonard Euler advanced some work in number theory and discovered that when you apply the properties of imaginary numbers, you come up with applications to the real world. They applied it to electricity. Anybody know the 2 types of electricity that we have? Alternating current and direct current. Your cell phones, do they work off of alternating current or direct current? Direct, because they have a battery, right? The smart board, is it operating off of alternating current or direct? Alternating. If we only had direct current, you would have to have a power station on every block of Albert Lee in order to power the things around it. The school would probably have 2 power stations itself. Okay? But because we have alternating current, which was developed through imaginary numbers, we can now have one power station all available to weak. So imaginary numbers, we won't talk about them too much in this class, but there's a lot of study with them, and especially in trigonometry, we have amazing studies of imaginary numbers. We just don't quite get to the full depth. Those are all examples. We don't really talk about them. Okay, so within these real numbers, we have one more set. We have irrational. So we have these rational numbers, but we have some numbers we haven't talked about yet. Any idea what they are? Do you know what an irrational number might be? Pi would be an example of an irrational number because it goes on forever and it never repeats itself. You got an idea of another one? Square root of 2. I'll give you one that you will reference a lot within this class is, say, sine of 36 degrees. You will type that into your calculator and you'll come up with a decimal approximation. But the fact is, it is an irrational number. Okay. Let's practice the first type of questions that you'll see on your test. It says, write an inequality for the following and graph the set. So I want to take 3, 5 and write it as an inequality and graph it. I usually think that providing the graph is the easiest thing to start off with. I will plot 3 and 5. Do I have an open circle or a closed circle on the 3? How about the 5? And I'll join them together, and that is my graph. I notice that many of you can do that rather easily. Here's where you may struggle, the inequality part. X is all the numbers that fit within that set. You can see that X sits between the 3 and the 5, correct? So I'll put the 3 down, the 5 down, I'll put the X in between them. How does the X compare to 3? Is it bigger or smaller? So X is bigger than the 3. Can it be equal to 3? Yes, it can, due to that bracket. The X compared to 5. It is smaller than 5. So the X is smaller than the 5. And it can be equal to. So there's our inequality. We'll try another one together. Negative infinity to 5. This time, instead of plotting both numbers, I just plot the 5. Because infinity is not a number. It's an expression for very large numbers. Okay. Open or close circle on the 5. Which way will the arrow go? To the left, towards those negative values. Now again, I put X in the area where you can, you have solutions that would work. How does this X compare to the 5? It is less than the 5. Can it be equal to the 5? No, so I don't write an equal sign. Why don't you try B and D on your own? When you think you have an answer, come and put it up on the board. If you get it wrong, we will not laugh. There's your 2 solutions. Did I do anything incorrect? You okay? Are there any questions how I came up with that? Going once? Yes. So the way that we read this is if you have some people will write it like this. They'll put negative 23 less than or equal to the X. These are technically the same statements. The important thing is that the bigger part of the inequality sign is attached to the X. Okay, that's what you need to make sure of. Okay. All right, we flip it over. You can cross off B and D because it'll be a little bit redundant. Well, let's try the same thing, except this time, instead of being given the inequality, or I'm sorry, instead of being given the interval, they give us the inequality. So I'm going to still make the graph first. That's what I like to do. Open or close circle on the -3. Open or close on the 9. So now I'm going to write the interval. And the interval will be -3, 9, 9 as the bracket. You try C on your own. Try C on your own. Any questions on C? So for the first part of your test, if I ask you about inequalities and intervals, how do you think you can get those points? Yeah. We'll give you some practice today in your assignment. First thing we're going to do is just review a little bit of these pieces real quick and we'll be good to go, okay? So absolute value is what we want to do. Absolute value 9 minus 16. What do I do first? Do I make everything positive or do I do 9 minus 16 first? I do 9 minus 16, which is -7. Then when I apply the absolute value, that's where I make it positive. Or I answer this question. How far is -7 from 0 on the number line? It's 7 units. That's technically what it's asking you. Okay? But your answer will be positive. Okay. This one, it says 10 minus 5 times the absolute value of -1. First, I evaluate what is the absolute value of -1. It's 1. Do I do 10 minus 5 or do I do 5 times 1? I get 5. Letter C, I have multiple absolute values of the absolute value of 3. That's the absolute value of -2 divided by the absolute value of -2. What is the absolute value of 3? Absolute value of -2. I get 1/2 as a result. Yep. Oh, I did. I'm sorry. All right. Radicals is something we deal with later on. And so that's going to take us through our assignment for the day. And here is your assignment that I'll put up for you. So it looks like you have a fair amount of time to work on it. Yep, right up there, right above. You got to go back by my desk a little bit to get one. Go ahead. So real quick, as you guys see the assignment, I want you to know that it says, it gives you a bunch of directions for 19 through 28. You don't really have to focus on the directions so much as just do what we did in class. So if you see x less than or equal to 5, that's an inequality. So then you need to make a graph and provide an interval. if they give you an interval, say 1, 10, then you would need to provide a graph and the inequality. They say give a verbal description as well. I'm not concerned about you doing that right now. Just do what we did in class for those problems. Does that make sense? Okay. Many of you should be able to finish your assignment by the end of the hour even. Is this technically due on Monday? No, it's due the day that we have the test. But much better to do it today than the day of test, right?